Hi class, it's Mrs. Perone and we are back again on page 13 of your shiny math book. We're going to jump right into it. The topic here is subtracting positive and negative integers. So we're going to start right at the top. Number 6 says, Fran rewrites a subtraction problem as an addition problem. The addition problem she writes is -3 plus -4. How could you use a number line to help you write -3 plus -4 as a subtraction problem? Well, why don't we draw a number line to find out? I'm actually going to use this line here to be my number line. And -3 plus -4 in a number line would look kind of like this. We'll go 0, and then let's go to the left. Maybe, I don't know, this looks like about 10 to me, so maybe not quite that far. I'm going to count by 2s, -2, -4, -6, -8. That should be far enough. So if we were to model this on the number line below, we would start at 0, go 3 units to the left, and then go 4 more units to the left. 1, 2, 3, 4. So there's my -3, -4 more, and we would stop right here, which is at -7 on the number line. So the way that we could use a number line would be to well, this is how you would model the integer addition on a number line. And then if you wanted to write it as a subtraction problem, you could do the opposite of keep, change, flip, which is how we learned to write subtraction as addition. Or you could look at the number line and say, we are going from 0 to -3, that's -3. And then we are subtracting 4 more. We're going 4 more to the left. So we are adding -4, which is the same as subtracting 4. So this little expression, -3 plus -4, is the same exact thing as -3 minus 4. These are the same thing. And both would be modeled on the number line in the same way. So look back at problem 6. What was Fran's original subtraction problem? So we kind of gave you the answer here. The original subtraction problem was -3 minus 4. And if you want to check your work, you could apply keep, change, flip to this and see if you land right here. So remember, we do keep. We keep the first number the same. The first number is -3. We change the subtraction to addition, and then we change the sign of the second number. So +4 becomes -4. And what do you know? We landed at exactly the same thing as this. So these two are the same thing. Make sure that you are doing each step. Leave the first one alone, change subtraction to addition, and change the sign of the second number. So the problem does say, explain how you got your answer. I would probably just write arrows and draw attention to each little part. So for the first part, we leave the first number alone. Or leave it the same. Don't ever change it. So I'm going to use some abbreviation here. So we change the subtraction to addition. I'm going to use a little minus sign in parentheses to represent subtraction, and a little plus sign in parentheses to represent addition. So we change the subtraction to addition. And then the third thing we did was we changed the sign of the second number. Or of the last number. And when I say change the sign, what I mean is if it's negative, turn it positive. And then if it's positive, turn it negative. In this case, it was a +4 and we changed it to a -4. Problems 8 through 10 are going to involve the same number line which we are about to draw. So draw a number line showing the integers from -5 to 5 and use your number line for problems 8 through 10. So before we start this problem, we're going to do what the directions say. We're going to draw a number line showing the integers from -5 to 5. So give yourself a nice long horizontal line. Let's put 0 right in the center. We're going to count 5 to the right, and 5 to the left, Don't worry if they're not exactly evenly spaced. If you've got something like this, that's good enough. So now let's answer the questions. What is the distance between 2 and 3 on the number line? Okay, so pretty easy question. The distance between 2 and 3 on the number line would be 1 unit, or just 1. So the distance between 2 and 3 on the number line is 1. The next part of the problem, we have some notation that you might not be familiar with. It's these two little vertical lines around 3 minus 2. And those little lines are called absolute value. So when something is in the absolute value symbols, I'm going to just do it on a little post-it note here. When something is in the absolute value symbols, what that's asking you is, how far is this thing from 0? So how far is whatever this number is from 0? And since we're talking about distance, right, how far we're talking about distance, distance is always positive. So basically you can think about the absolute value signs as kind of a little car wash. Whatever goes in there, whether it's positive or negative, when it comes out, it's always positive. So we're going to take that information. What is the absolute value of 3 minus 2? Well, if I were to crunch the numbers inside the absolute value symbols, I would come up with the absolute value of 1. So now it says, how far is 1 away from 0 on the number line? Well, the number 1 is 1 unit away from 0 on the number line. So the absolute value of 1 is 1. How about this one? What is the distance between -3 and -2? Well, the distance between -3 and -2 on the number line, again, here is 1. And what is the absolute value of -3 minus -2? So I'm going to take that stuff inside here. I'm going to move it over here and deal with it. So -3 minus -2. I'm going to use what I know, keep, change, flip to rewrite this using addition, and then check it. You could also check it with your calculator. So leave the first number the same, change the subtraction to addition, and change the sign of the second number. So -2 becomes +2. So my new addition expression says -3 plus 2. So let's see what that would be on the number line. So -3, 3 to the left, plus 2, going 2 more to the right, we would land here at -1. So -3 plus 2 is -1. But this question is asking me, what's the absolute value of that? So what is the absolute value of -1? In other words, how far away from 0 is -1? And on my number line here, I can see -1 is 1 unit away from 0. Therefore, the absolute value of -1 is +1. Remember, absolute value is always positive because it's talking about the distance, and distance is always positive. Okay, let's try number 9. What is the distance between 4 and 1 on the number line? Well, let's see here. The distance between 4 and 1 is 1, 2, 3, is 3. The distance between 4 and 1 on the number line is 3. So what is the absolute value of 4 minus 1? Well, the absolute value, let's see, 4 minus 1 is 3. So the absolute value of 4 minus 1 is the same as the absolute value of 3. And now it's asking you, how far is 3 away from 0 on the number line? Well, the number 3 is 3 units away from 0 on the number line. So the absolute value of 3 is 3. What is the distance between -4 and -1? Well, let's head over here. The distance between -4 and -1 is 1, 2, 3. So we have a distance of 3. The distance between -4 and -1 is 3 units. And what is the absolute value of -4 minus -1? So let's just take the stuff inside the absolute value symbols and do what we know how to do with it. We're going to keep the first number the same, change the subtraction to addition, and change the sign of the second number. So -1 becomes +1. So we are at negative 4 plus 1. So head up to your number line. Negative 4, 1, 2, 3, 4 to the left, plus 1. So head one more to the right. You would land at negative 3. So this is the number that belongs inside the absolute value symbols. So we want to know the absolute value of negative 3. In other words, how far is negative 3 away from 0 on the number line? So negative 3 is 1, 2, 3 units away from 0. Therefore, the absolute value of negative 3 is 3. Remember, the absolute value is always positive. The absolute value symbols are kind of like a little car wash. Whatever number goes into them comes out nice and clean and positive. If it's positive, leave it positive. If it's negative, turn it positive. So number 10 says, look at your answers to problems 8 and 9. Okay, problems 8 and 9. Look at my answers. So my answers were 1, 1, 1, 1. They were all the same. And then in 9, 3, 3, and 3. My answers were all the same. What do you notice about the absolute value of the difference between two numbers? So that question is referring to the last sentence in problems 8 and 9. And this again is a lot of vocabulary. The absolute value of the difference between two numbers. So this little piece right here is the absolute value of the difference between two numbers. And same thing here. This little part here is the absolute value of the difference between two numbers. So if I were to bring this one down so you can see what I'm talking about here, the absolute value of the difference between two numbers might look something like this. And by the way, I'll make these thicker so that they don't look like ones. Those are absolute value symbols. So what this says is the absolute value of the difference, subtraction, between two numbers. So what do you notice about the absolute value of the difference between two numbers? What I notice here is that I got the same answer as what is the distance between those two numbers. So the absolute value of the difference is the same as the distance between those two numbers on the number line. So the absolute value of the difference between two numbers is the same as the distance between those numbers on the number line. And at this point, you might want to pause the video and give yourself time to write, but since I know you can pause the video, I'm just going to keep on rolling. Number 11, write an absolute value expression to represent the distance between -2 and -4 on a number line. Okay, so some of that sounds similar to what I wrote above here. Write an absolute value expression to represent the distance between -2 and -4 on a number line. Okay, so the absolute value, what we're talking about is the absolute value of their difference. So we're going to be subtracting them and we'll put them inside the absolute value symbols. So this is going to be the absolute value of their difference. So -2 minus 4. So if I crunch these numbers down to a single number, that's going to tell me how far apart those two numbers are on the number line. So let's do that. So we're going to rewrite this expression on the inside using keep, change, change. We keep the first number the same. We change the subtraction to addition, and we change the sign of the second number. So +4 becomes -4. And your absolute value symbols are kind of like grouping symbols or like parentheses. So keep that in mind for the purposes of order of operations. So now let's do -2 plus -4. So they're both negative and I'm adding them together. So when you add two numbers that are both negative, you just add them as if they were positive and put a negative sign in front. So -2 plus -4 is -6. So the absolute value of -2 plus -4 is the absolute value of -6. And remember, your absolute value symbols are like a car wash. So whatever number you put in there, it washes it. If it's negative, it comes out positive. The absolute value of -6 is 6, because -6 is 6 units away from 0 on the number line. So to go back to the question, we wanted to know the distance between those two numbers on a number line. I think the distance between those two numbers is 6, and I'm going to prove it to you right here with my number line. Let's see, let's put 0 right there. So -1, -2, 1, 2, 3, 4. So there's 2, and there's 4. I'm sorry, -2 and 4. They are 1, 2, 3, 4, 5, 6 units apart, just as I suspected. So I hope your notes are complete and looking good, and I'll see you in class. Bye.